All right, guys, I wanted to go ahead and take a little bit of time and review a bit of chapter 7, what we've been talking about with this whole revolutionary volume. So we're taking these regions and we're revolving them around a axis. And when we do that, we're either going to use disk, washer, or shell method in order to find that volume. Okay, so what we want to take a look at here is this region, this y equals x minus x cubed, and the x-axis in the first quadrant. And we're going to revolve it around a whole bunch of different things and kind of pick out which is the best method to use and just set that up. We're not going to actually evaluate these. We're just going to set them up, just kind of review these topics that we've talked about so that we're ready for our chapter 7 test. All right, so let's start off. Every time we deal with this, we want to make sure that we are actually sketching the graph. So we got y equals x minus x cubed. Now we have a cubic graph, and whenever we have a cubic graph, we do know that, especially in this case where it's not just a basic transformation, we've got to find those zeros. So we're going to set it equal to 0. We're going to factor out an x. All right, we're going to get x equals 0, and then x equals plus or minus 1. So here we get negative 1, 1, 0, and now be careful here. This is x minus x cubed. So since it's a negative lead coefficient, it's going to go down and then up and down, something like that. And so we're looking at the region in the first quadrant. So we're looking at this region, since we're also using the x-axis. That is going to be our shape that we are going to revolve about all these different things. So let's start off with just this. All right, let's go ahead and start off with something easy. Let's do the x-axis. So our first one that we're going to do is the x-axis. All right, so amount. All right, so if we take this around, let me go ahead and we're going to use this picture a lot for this one. So let's go ahead and group that all together. If only we could do this on paper, that'd be super nice. All right, so we're going to take this about the x-axis. So that means this shape is going to spin down here. And what we're getting here is all of these circles. Now, this is a horizontal revolution. So remember, whenever we use horizontal revolutions, we want to go ahead and use either disk or washer. Okay, we save that vertical revolution. We save shell for the vertical revolutions. And we see here that this whole shading is really flush against that axis of revolution. And since there's no space there, we're going to use our disk method. Okay, remember disk method is pi a to b r squared dx. Okay, so first off, we need to know what our a to b is. What is this shaded from? And we can see that it's going to be shaded from 0 to 1 on the x-axis. And then we got to figure out our r. Okay, well, let me just get this guy out of here real quick, maybe. Let it catch up. Give it a second. All right, so remember, whenever we're trying to find our r, we always start on the axis of revolution. Okay, so here we're going to actually start right there on the axis of revolution, and I'm going to go up through the shading, and you can see that that makes the radius of my circle. All right, so that's my radius, and whenever we do our r, we're still doing our top minus bottom. And so our top in this case is going to be the function. All right, so r is going to be our x minus x cubed, and our bottom is going to be that 0, okay, the x-axis. So put that in, x minus x cubed squared dx, and there's our setup for that. If we wanted to evaluate this, we would actually have to go ahead and FOIL that. All right, but in this case, we're just going to do our setup. All right, let's do the same picture, but now we're going to revolve it around the y-axis. All right, so let's bring our picture down here. Maybe. There we go. Okay, now I'm going to get rid of this side because we really don't need this side. We really just need our inside there. Here we go. All right, so we are going to take this now around the y-axis, and now we have a vertical revolution. So anytime we use a vertical revolution, really it makes the most sense to use our shell method. Okay, so using our shell method, this actually will make this much easier. Remember, that is going to be 2 pi a to b RH dx. Okay, so with that, again, the nice thing about using shells, we can keep everything in terms of x. So we got 2 pi a to b, our interval is still going to be 0 to 1. But now we got to find out what that r and the h is. So again, we start on that axis of revolution. We go over until we hit our first function there and then go down through the shading. So this is our r and this is our h. Remember, shell is all about kind of making these cylinders or shells. Okay, and that you can see it makes our circle for our cylinder and then the height there of the cylinder. So the height, nice and easy, our height is top minus bottom again. So top minus bottom is going to be that x minus x cubed minus 0. Now our r, the r you got to be careful with. That point that is on our graph, we call that x. And so we're going to do right minus left for r this time. So right minus left, this is going to be x minus 0, okay, because our left point is actually on the y-axis. That would be x equals 0. And so if we put this together, this is going to be x times x minus x cubed, again, dx. And that's it. There's our setup for that. This would be a nice, easy one to evaluate. We could go ahead and just distribute and then integrate. Okay, let's try another one. So using that same picture there, now we're going to take it about y equals 5. All right, so let's bring down our picture here. Now y equals 5 is going to be up here. All right, y equals 5 is somewhere up here, and we're going to take it about this line. So it's horizontal. Okay, it's horizontal, but notice there's all this space going in between here, between the axis and our shaded region. And so we are going to use washer because of that. And remember, washer is pi a to b, big R squared minus little r squared dx. Okay. So again, we got our pi a to b is still 0 to 1. Isn't that nice? Big R, we start on the axis again. Okay, always start on that axis of revolution, go down all the way until you get through all the shading. And you'll see that if we were to actually revolve this, makes our big circle for that picture. Okay, so our big R here, I'm going to do it down here, top minus bottom. Okay, the top is actually the 5, minus the bottom is the 0. So big R is actually just 5. And little r, okay, little r, we're still going to stay on that axis, and we're going to go down until we hit our first line. All right, there's our little r, and you see that makes our little inside circle of our washer. Okay, so our red line there is the big R, the blue line is our little r, and so the blue line, top minus bottom, is going to be 5 minus parentheses x minus x cubed. All right, so we're going to put that into our formula. So we get 5 squared for our big R squared minus little r squared is going to be 5. I'm going to distribute the negative in there. Minus x plus x cubed squared. Move everything over a little bit here because we need to make sure we get that dx there. And there we go. All right, so here's our washer method. All right, now let's take it about x equals 7. All right, dx equals 7. So we're going to take it for another vertical one. All right, and so here is x equals 7, way over here. I know that's not really drawn to scale, but you get the idea. We're taking around another vertical line. So again, I'm going to use shell since it's vertical. So 2 pi a to b RH dx. So again,
2 pi, a to b, 0 to 1, hasn't changed any. We need to find our r and our h. So we start on the axis, go over until we hit that function, and then down through our shading. So we have our r, we have our h. All right. Again, h, nice thing about shell, if you're using the same picture, that h isn't going to change at all. You got x minus x cubed minus 0, top minus bottom. Right minus left. Now r, remember we said last time, this point on here is always going to be x. And we're doing right minus left. Well, this point is at x equals 7. So it's going to be 7 minus x. And so we'll put that in there, 7 minus x times the x minus x cubed. And let's flip that over, get our dx in there because we don't want to forget that dx. Okay, and hey, there's our setup. We're all done. And if we wanted to evaluate this, we would FOIL this out and find out what we got. Okay, so R, when you're dealing with shell, is always going to be either x minus a number like it was in the first one we did with shell, or a number minus x like it is here. All right, it all depends on where that vertical line is. Is it to the right or is it to the left of your region? All right, let's do 2 more. All right, let's do x equals 1. So if we do x equals 1, that is going to put us right here. I missed. Slide it over a little bit. There we go. All right, x equals 1. So we're spinning it around another vertical line. So again, I'm going to use shell. I'm just going to keep it going just like last time. Okay, so we're going to use shell. We got 2 pi, a to b, still 0 to 1. We got to find our r and our h. So let's start on the axis, over until I hit the first function there, and down. Here's our r, here's our h. All right, take a second. H, still the same thing, x minus x cubed minus 0. And our r, again, this point here is x. This point here is 1, right minus left, that's 1 minus x. So we got 1 minus x, and then x minus x cubed for h dx. Excellent. All right, so the more you practice these and just setting these up, this actually gets easier and easier as you go. All right, we're going to do one more, same picture. Finish out this picture, and let's do one more horizontal revolution. Let's take this about y equals -2. All right, so y equals -2 is going to be down here somewhere. Okay, and so notice here's your shaded region, and here's our line. There's all this space, so I'm going to use washer again. All right, just remember washer. We got that pi, a to b, big R squared minus little r squared dx. So again, pi, a to b is still 0 to 1. Love when we're working with the same picture. And we got to find big R and little r. So big R, start on the axis, all the way up through the shading. That's going to be your big R. Okay, so big R here, top minus bottom. The top is your x minus x cubed minus the bottom. The bottom is actually -2. Okay, and so we can simplify that to x minus x cubed plus 2. And little r, we start on that axis, go up until we hit the first line. All right, so little r is actually going to be top minus bottom 0 minus -2, which actually just gives us +2. So if we put all that together, we get big R squared, x minus x cubed plus 2 squared minus little r squared, and then dx. All right. So there you have it. We went through one shaded region, but we went ahead and revolved it around 6 different things. And we practiced setting up using disk, washer, and shell. All right, so all this is a large portion of the test coming up with chapter 7 is just a lot of setup. Okay, even on the AP exam, we see a lot of questions where it's just setup
the integral so that we can find the volume of these. Okay, so keep practicing your revolving your shaded regions, keep practicing setting up your disk washer and shell, and you'll be good to go for volume tests.